Our final section in this chapter is about oxidation reduction reactions. So we're going to be able to determine oxidation numbers of elements in a compound and understand that these numbers represent the charge an atom has or appears to have when the electrons of the compound are counted according to a set of guidelines. We're going to recognize common oxidizing and reducing agents and then identify oxidation reduction reactions, also called redox reactions. Identify the oxidizing and reducing agents and substances oxidized and reduced in the reaction, and then write and balance equations for redox reactions. I want to start with this video. I think they do a really great job of introducing what oxidation numbers are, some rules, some examples, and then we will continue with our PowerPoint and some more examples that I have.
It's important to know if an atom loses or gains electrons when combining with other atoms to form compounds. How do we keep track of the electrons lost or gained by an atom? We do this by looking at an atom's oxidation number. An oxidation number is a number that is assigned to an atom in a substance. The oxidation number could be positive, negative, or zero, and it indicates if electrons are lost or gained. In other words, the oxidation number is a number that helps us keep track of electrons in an atom. Here, the oxidation number of calcium is +2 and the oxidation number of oxygen is -2. If the oxidation number is positive, then this means that the atom loses electrons. And if it is negative, it means the atom gains electrons. If it is 0, then the atom neither gains nor loses electrons. Calcium has a +2 charge, which means it lost 2 electrons. Oxygen has a -2 charge, which means it gained 2 electrons. If an atom loses electrons, its oxidation number is positive, so we can say that this atom undergoes oxidation. If an atom gains electrons, its oxidation number is negative, so we can say that the atom undergoes reduction. You can remember this by thinking of the phrase oil rig. O, oxidation, I, is, L, loss of electrons, R, reduction, I, is, G, gain of electrons. Oxidation is loss of electrons, reduction is gain of electrons. In chemistry, it is important to follow a set of rules to assign oxidation numbers. Here are the most important rules and exceptions to remember when assigning oxidation numbers. Rule 1. In its pure elemental form, an atom has an oxidation number of 0. What exactly is a pure element? A pure element is an atom that is not combined with any other elements. This table shows examples of atoms in their pure elemental form. Take note that even though the element has subscripts like the 2 in O2 and the 8 in S8, these are still considered pure elements because they are not combined with any other elements. Rule 2. The oxidation number of an ion is the same as its charge. An ion is an atom with a charge due to the gain or loss of electrons. The charge is indicated as the superscript after the atom. If an atom has this, then this means that it is an ion. For example, the potassium ion has a +1 charge, so the oxidation number is +1. For the bromine ion, the charge is -1, so the oxidation number is -1. It is important to note that if only a positive or negative is shown, the charge is assumed to be positive or -1. Here's another example. The barium ion has a +2 charge, so the oxidation number is +2. For the sulfur ion, the charge is -2 and the oxidation number is -2. Rule 3. The oxidation number of metals is +1 in group 1 and +2 in group 2. Unless it is in pure elemental form, the oxidation number of a metal is +1 in group 1 and +2 in group 2.
We will get to some more rules in just a minute, but I do want to pause and I want to look at some examples and how we can apply this. So let's look at this thermite reaction. This is an oxidation reduction reactions. And this is where we're going to look at what oxidation numbers everything has in this reaction. So we know this is iron 3 oxide, and we know that this iron has a +3 charge because of this 3 in the oxygen, and oxygen we know is always -2, always. So we could actually, I would recommend starting with what we know in this compound. Oxygen's always, always, always -2. So if I have 3 negative 2's, that means that this side has got to equal positive 6, and there's 2 iron, so that iron has to be plus 3. And then remember the rule that said all elements by themselves have an oxidation number of 0. And then we look over on the right side of the equation. Iron is by itself. It has an oxidation number of 0. And then we have aluminum oxide. Again, oxygen is always negative 2. So therefore, aluminum must be plus 3. Okay, now let's look at what's happening. Charges on bonded atoms are assigned by giving the more electronegative atom all the shared electrons, and these charge assignments are called oxidation numbers. Electrons are transferred between reactants. Now, oxidation is the loss of electrons. Like they said, oil, oxidation is the loss of electrons. And what's important to know is that that means our substance is becoming more positive. If we lose electrons, we become more positive. Think of lithium. Lithium always becomes a +1 ion because it gives away an electron. It loses electrons. So oil, oxidation is losing electrons. It becomes more positive. The reduction is gaining of electrons. So reduction is gaining. Oil, rig. And if it's gaining electrons, it becomes more negative. You can also use the phrase, Leo the lion goes grr. Leo is the loss of electrons is oxidation. The loss of electrons is oxidation, Leo. The lion goes grr. The gain of electrons is reduction. So whichever way you're able to remember. Now let's look at this. We have iron on the left side with a positive 3 oxidation number, and we have iron on the right side with an oxidation number of 0. What happened to iron? Let's look at aluminum. Aluminum on the left has an oxidation number of 0, but after the reaction, aluminum has a +3 oxidation number. What happened to aluminum? Well, one of them was oxidized and one of them was reduced. So which one became more positive? Positive 3 to 0 or 0 to positive 3? Definitely the 0 to positive 3. So we can say that aluminum was oxidized, or it underwent oxidation. And our iron, or we would say our iron oxide, we look at the whole compound, but specifically that iron oxide was reduced or underwent reduction, because look at that iron, it went from +3 to 0, it became more negative. So like they said, there are some rules. Number 1, each atom in a pure element has an oxidation number of 0. For monatomic ions, like Li+, the oxidation number is equal to the charge of that ion. Or if I said Ca plus 2 plus something else, the oxidation number is that charge for monatomic ions. When combined with other elements, fluorine is always -1. And I actually don't know why we have a special rule for number 3 and for number 5, because fluorine is a halogen. So pretty much all halogens are always -1. Oxygen is always -2. Oxidation number of hydrogen is +1. There, I fixed this. I just made that rule all in one rule where halogens have the oxidation number of -1. And I did make a addition because we said oxidation number of hydrogen is +1 in all compounds, except, there is an exception, in binary and ternary compounds where the only other atoms are metals or boron. And I'm going to show you an example of that later. And the sum of the oxidation numbers for atoms in a neutral compound must be 0. If it's in a polyatomic ion, the sum has got to be equal to the charge of that polyatomic ion. Let's look at an example. Let's say I have calcium plus 2 hydrogen ions yields calcium plus 2 and hydrogen gas. Okay, so let's assign oxidation numbers. We have calcium just by itself, 0 oxidation number. Over on the right, I have hydrogen by itself, 0. And then obviously I have my H plus and my Ca2 plus. So those are those oxidation numbers. Let's look at what's happening from left to right. Calcium went from 0 to positive 2. Hydrogen went from positive 1 to 0. So Leo, the lion, goes grr. The loss of electrons is oxidation. Oxidation becomes more positive. Or again, if you want to say oil, rig. Who became more positive? Calcium did, right? Calcium went from 0 to positive 2. So calcium has been oxidized. Calcium is oxidized or underwent oxidation, forming Ca plus 2. Therefore, our hydrogen ion is reduced, right? We went from H plus to neutral, so it gained electrons. It was reduced. When one reactant loses electrons, another reactant must gain them. That is what this oxidation reduction reactions are showing. The oxidation of one substance is always accompanied by the reduction of another as electrons are transferred between them. Now let's look at some examples where sulfur is involved. What's the oxidation number of sulfur in the following? Okay, well, we said H is always plus 1. So if there's 2 plus 1s, the left side of my neutral compound is plus 2, so sulfur must be minus 2. All right, let's look at SCl2. We don't know what sulfur is, but we always know that those halogens are negative 1. And there's 2 negative 1s. So this half of my neutral compound is negative 2. So therefore, the half with sulfur must be positive 2. And there's 1 sulfur, so sulfur would be positive 2. What about Na2SO3? Okay, well, we know Na is in that very first group, my alkali metals, and they're always positive 1. And I have 2 positive 1s, so this half of my compound is plus 2. So this half of my compound must be negative 2. All right, well, we know oxygen is always negative 2, so 3 times negative 2 is negative 6 for my O's. So what must sulfur be in order to still be a negative 2 on this side? Well, it must be plus 4, right? Because plus 4 minus 6 is negative 2. That was a hard one. How about this one? Sulfur tetroxide, SO4. Again, we know oxygen is always negative 2, so 4 negative 2s is negative 8. So sulfur must be plus 8. How do you feel about that? Why don't you pause the video here and try to figure out what the oxidation numbers of the elements in each of the following compounds are. Let's look at these and see if it makes sense. We've got carbonic acid here, so we have H2CO3. Now we know that CO3, this half of the compound is negative 2. We know hydrogen's plus 1 here. And so this half of the compound is plus 2. Oxygen's always negative 2. So that would give this part a total of negative 6. So carbon must be plus 4 to give that carbonate an overall negative 2 charge. So plus 1, negative 2, and plus 4. N2 just by itself, 0. All right, let's look at the CaCr2O7. We know calcium's a plus 2, so therefore this half must be minus 2. There are 7 oxygens. Each oxygen is negative 2, so that would be negative 14. And therefore, this must be plus 12 in order to have that overall negative 2. So each Cr must be plus 6 because there's 2 of them. NO2 minus, so that's nitrate. NO2 minus. Each O is negative 2, so that'd be negative 4. Negative 4 plus what is equal to a negative 1? Well, that must be 3. Here's an example of that hydrogen. example. We know lithium is always +1 and it's a metal, so hydrogen must be a -1 in this case. Now this one, this is iron oxide, Fe3O4, and let's look at this. Oxygen's always -2, Fe3O4, -2. So that gives this half of the compound a -8 charge. So that means this must be a +8 charge. And there's 3 of them. Well, that's not going to be an easy number, but we can just make it a fraction and say it's +8/3. That makes this each iron equal out to make this compound neutral. For each of the following, we want to balance the equation, identify the reactant that's oxidized and the reactant that's reduced. Now I'm throwing in 2 new terms for you, oxidizing and reducing agents. So here's the thing. When we find out who has been oxidized, the species that's oxidized is the reducing agent. And when we find out who is reduced, it's the one that's the oxidizing agent. So why don't you pause the video, first try balancing, assign oxidation numbers, figure out who is being oxidized, who is being reduced, and then label accordingly which agents are whom. All right, I went about balancing, so see how you did there. Check your oxidation numbers, see if we match. And then I matched up what was happening from left to right, the changes. Now let's identify who is whom. My hydrogen in my hydrogen chloride went from +1 to 0. My zinc went from 0 to +2. It's easiest for me to pick out who became more positive, which is what's being oxidized. So my zinc is being oxidized. And my hydrogen then, let's double check, is it being reduced? Yeah, it went from +1 to 0. So my HCl is being reduced. Therefore, the zinc that's being oxidized is the reducing agent. And hydrochloric acid is the oxidizing agent. I'm going to abbreviate there. Okay, let's look at example 2. Changing color. My copper went from +2 to 0, and the aluminum went from 0 to +3. So again, it's easier for me to see the drastic going to positive here. So my aluminum became more positive. My aluminum was oxidized, which means it's the reducing agent. And therefore the copper chloride, remember we looked at that whole unit, the copper chloride is being reduced, and so it's the oxidizing agent. Okay, then we have sodium plus chlorine to give us sodium chloride. So the sodium went from 0 to +1. So our sodium was oxidized, so it's the reducing agent. And our chlorine went from 0 to -1. So the chlorine is reduced and is the oxidizing agent. All right, I have 4 join-in questions, so please feel free to pause and then I will give those answers like always.